and share my screen and start by, whoops, looking at your class. So today, hopefully we'll finish looking at rational expressions. It might be like a day and a half worth of work, but we should definitely be all done with it by the 19th. Hopefully on the 19th, we will go over that problem set to kind of get you guys ready for that test. It should be done over the weekend. We'll see how far we get today, hopefully we won't have to delay that, push that back further. But tentatively, that's where things are right now. Problem set 5 is the one that was with factoring. That should be, could you guys mute if you're not talking, please? Problem set 5 is the one on factoring. That should be done by the end of the day today. Problem set 6 is the one that involves those rational expressions. And again, if we need to adjust that depending on how far we get today, so be it. Well, people are really coming in late. I'm sorry. I shouldn't make you guys wait for people who weren't here on time. Before we get started, does anybody want to look at any questions from any of the homework assignments, especially 5 factoring or 6 rational expression? Any questions?
Can you do 24 from the homework that's due today?
Homework 5, sure, nothing. If I can get the computer to respond to my question number 24, you said?
Yeah.
Okay. Factor using the formula for the sum or difference of 2 cubes. So what we have here is 27x to the third minus 1. And they tell us that they're cubes. They also, the fact that the exponent is a multiple of 3 would be a sign that I'm working with 2 terms of binomial with cubes. First of all, you need to know the pattern that here I have a difference. A cubed minus b cubed is going to equal, it will always be the difference of the cube roots, a minus b, times the first one squared. If this is subtraction, we'll put a plus sign, take the product of those roots, ab, then add the last one squared. So as I look at what I've got here, hopefully everybody recognizes 27 as 3 to the third. So this first term is 3x quantity cubed. We do have that subtraction, and 1 we can think of as 1 to the third. So 3x is going to take the place of a, 1 is going to take the place of b. Or I'm going to take the difference of those cube roots, 3x minus 1. Then I have to square that first one. Well, if I take 3x and square it, I'll have 9x squared. Because this is a minus, this middle sign will be the opposite, a plus. And then in the middle term, we're going to take the product of the two, 3x times 1 will give me just 3x. And then in the end, we're going to add the last one squared. 1 squared is 1. And so this will be that factored form. And again, what you need to do is recognize that we've got cubes and remember the pattern. Instead, if that were addition, if that were a cubed plus b cubed, pardon me, if it were addition instead of subtracting in the beginning, I'd have a plus b. I'd still start with a squared. I'd still end with b squared. But in the middle, because this one's a plus, the opposite sign would make this a minus ab. And they're just patterns that you need to be familiar with. Better?
Yeah, so this is the formula used for this kind of problems.
Right. If I have a binomial and they're cubes, it's going to be one of these 2 formulas, depending on whether I have addition or subtraction.
Excuse me?
Yes?
How can you determine a polynomial is a prime?
A polynomial is a prime if you can't factor it.
Okay.
And so, for example, instead of 27x cubed, if that were 3x cubed minus 1, well, 3 is not a perfect cube. It doesn't fit this pattern, so then it would be a prime. I couldn't factor it. Okay, so you're good. The only time you're going to ever choose that choice that it's prime is if you tried absolutely every possible factor and it's not factorable. So to say that it's prime is a fancy pants way of saying that it's not factorable. I have no idea why when I use this writing on the screen in Zoom, my penmanship deteriorates rapidly. It doesn't let me draw smooth curves. It turns them into like a bunch of little sticks connected. I'm sorry about that. Does anybody want to look at any other homeworks?
Can we look at 28 as well?
Sure.
I just have a question about Friday's homework.
Yeah.
So what's the difference between the problem set and the part 6?
The problem set is a practice test. It's to get you ready for the test. I do believe that I changed that due date so that it's due on Saturday instead of Friday. I would strongly suggest that you go over it as much as possible so that you can be prepared for the test.
Is it graded too?
Yes, it counts as a quiz grade. It doesn't count as a homework grade, it counts as a quiz grade. And again, you get to do it over and over and over again. But because it's getting you ready for the test, you don't have the help functions and you don't know whether you got it right or wrong until you finish the assignment.
Okay, thanks.
And even though it counts for a quiz grade, those quizzes I am not asking you to turn your work in for. Okay, those are just, you know, again, it's to help you prepare for the test. And hopefully on Friday, we will go over one version of that so that you kind of prepare people for the test. But now as I look at 28, what's noticeable about 28 is that there are 4 terms. We've got x cubed minus 5x squared minus 9x plus 45. And usually when there's 4 terms, the first thing I do is I try that factoring by grouping. I split it in half and I look at these 2. Do these 2 have anything in common? Well, they both have an x and the lowest exponent is 2. So I'll say that my common factor is x squared. And when I divide that out, I'm left with x minus 5. Now I'm going to look at these 2 in the back. Do they have anything in common? Well, they're both divisible by 9. Because that first is a negative, I'm going to divide out a negative 9. When I take negative 9x and divide it by negative 9, I get positive x. When I take positive 45 and divide it by negative 9, I get negative 5. And all of a sudden, I notice these are the same, so I'm happy. One factor is x minus 5. The other factor, if I think of dividing that out, I'd be left with x squared minus 9. However, I'm not done yet because I'm looking at this, and this is a square, this is a square. A binomial where we're subtracting squares is still factorable. So let's see, difference of squares. I'll have x and x to get the x squared. I'll have a 3 and 3 to get a 9. And because it's negative, 1 will be positive, 1 will be negative. And so it's not going to accept it unless you continue to factor it until it's fully factored. Better?
Yeah, thank you.
You're welcome. Any others? If not, I'm going to get rid of this toolbar and go into the notes. And if I remember correctly, last class, we looked at what it took to simplify a rational expression, and we had left off with multiplying rational expressions. So let's look at one more example of multiplying rational expressions. And let's look at x squared plus 6x plus 9 over x cubed plus 27 times 1 over x squared minus 9. And does anybody remember my words of wisdom with these, that fractions are fun if you factor first, especially if you're simplifying and or multiplying. So I look at this as 1, 2, 3, 4 factored problems. Can anybody factor that x squared plus 6x plus 9 for me? Can anybody factor that x squared plus 6x plus 9? To get x squared, we can go x times x. For 9, if we use 3 times 3, signs are the same, both positive. When we check by FOILing, that would give me that 6 in the middle. Down here, the x cubed plus 27. We just looked at that pattern for the sum of two cubes. X plus 3. And then let's see, we have to square that first term, square x squared. If this is a plus, it'll be a minus, multiplying 3x, plus when I square that last one, I get 9. And this will be prime. That trinomial that you get, for the most part, will be prime. 1 is prime. Well, now, take that back. 1 is not prime, but 1 is not factorable. It's that basic unit. And then x squared minus 9. Hopefully everybody remembers that, factoring into x plus 3, x minus 3. Before I do my multiplication, I do believe in my labs, some of these questions ask you what values do you need to exclude. And it has something like x cannot equal. And I'm going to fill that in first, because now that I've got it factored, I'm going to think of setting each factor of a denominator equal to 0. X plus 3 equals 0 would give me -3. This one, because it's not factorable, we're not going to worry about. This one we said gives us -3. And then if x minus 3 is 0, I'd have to exclude 3. So there's two values that I would need to exclude. Now, does everybody remember, in order to multiply, we're going to actually just think of this as one great big single fraction, and we're going to divide out any factors common to the numerator and denominator. I call it, in my childishness, I call it playing matchy-matchy. Those guys match. Those guys match. So all that's left, my final answer would be 1 over x squared minus 3x plus 9 times x minus 3. And again, usually they say you can leave it in factored form. And does everybody remember doing that multiplication last class, where in order to multiply, it's almost the same as reducing. We just treat all the numerators as one great big numerator, the denominators as one great big denominator. And rather than multiplying them out, we actually factor them to see if there's anything that I can reduce. And again, 99.9% of the time, they're okay if you leave it in factored form. Is that problem all right for everybody? Can you guys hear me?
Yep.
Yep.
Everybody okay with that one?
Sure.
If we're all right with that, then we're going to move on today and look at some of the other operations. First, let's look at division of rational expressions. And let's start with a numeric example. Let's look at something like 5/8 divided by 1/2. Way back when, earlier in your mathematical career, when you were focused on operations with fractions, does anybody remember something like the phrase keep, change, flip?
Yes.
And what we do is we keep the fraction in front of the division. As it is, so we'll keep that 5/8. We change the division to multiplication. And then we flip, or we take the reciprocal of what we're dividing by, the divisor. And then we use multiplication rules. So to divide, what we do is we multiply by the reciprocal. And so now when I do this multiplication, I'd get 10/8, which would reduce to 5/4. And so if I have algebraic fractions, I'm going to first do that, rewrite as multiplying by the reciprocal. And then I'm going to use my multiplication rules. Factor everything. And simplify. What you have to be careful of is when it looks for values to exclude, we want to worry about any denominator equaling 0, both before and after we take the reciprocal. So in this little cubby hole of space that I left, let's see what that means. For example, let's have x plus 5/7 divided by 4x plus 20 over x plus 2. First, I'm going to rewrite it as a multiplication. I'm going to change that division into multiplying by the reciprocal. Then I'm going to factor what I can. X plus 5 does not factor. That would be prime. 7 does not factor. X plus 2 does not factor. But down here, 4x plus 20, there's a common factor of 4, leaving me with x plus 5. Now, because it's multiplication, I can think of that as all being a single fraction, and I can simplify, dividing out any factors that are common to the numerator and denominator, and I show that division just by crossing it out. So here, what's left is x plus 2 over 28. That idea of multiplying by the reciprocal, all right. Now, if I wanted to know what values to exclude, in looking at what to exclude, I have to look at every denominator, both before and after I take the reciprocal. And so, and let me highlight the excludes. You guys know why I highlighted that. So 7 equals 0, I don't have to worry about. X plus 2 equals 0 would give me x equals -2. And 4x plus 20 equals 0 would give me 4x equals 20. I'm sorry, -20, or x equals -5. And so for this, if it asks me what values I need to exclude, what x cannot equal, x could not equal -2 or -5. And so, be careful. If they ask that part of the question, we've got to look at the denominator both before we flipped it and after. So, that example having been done, I'm going to ask you folks to please divide. And the example is x squared minus 4 over x squared plus 3x minus 10 divided by x squared plus 5x plus 6 over x squared plus 8x plus 15. You can leave the quotient in factor form. And I want to know what values do I have to exclude when you're done. And I'm going to be quiet for a couple minutes and ask you folks to do that one. How are you guys doing?
Eh.
You do okay?
Yeah.
So first, rewriting it as multiplying by the reciprocal. X squared minus 4 factors into x plus 2x minus 2. X squared plus 3x minus 10 is x plus 5x minus 2. X squared plus 8x plus 15 is x plus 5x plus 3. And x squared plus 5x plus 6 is x plus 3x plus 2. When I play the matchy game, looking for common factors, I find that, wow, everything divides out. So my final answer is 1. In terms of what to exclude, if I look at it first denominator, when I set it equal to 0, I would have x plus 5 equals 0 or x minus 2 equals 0. When I look at that original second denominator, factor that becomes x plus 5 equals 0, x plus 3 equals 0. And when I look at that flipped denominator, that becomes x plus 3 equals 0, x plus 2 equals 0. So I get negative 5, 2, negative 3, and negative 2 as values to exclude. Then one last example. Let's look at Brooks. 25x minus x cubed over 4x squared times 2x squared minus 2 over x minus 6x plus 5 divided by x squared plus 5x over 7x plus 7. How fun is that? Should we
Very.
put this one together?
Sure.
So first, because there's division, we want to leave everything in front of the division as is. So both those first two fractions remain the same. The division becomes multiplication, and I take the reciprocal of the second. Again, off to the side, I'm going to say that if the question asks me what values I need to exclude, I have to set each of the original denominators to 0. And then that new denominator when I take the reciprocal to 0. So a lot to consider there. Before I do that consideration, I think it's easier if I factor this first numerator. Remember, whenever you factor, the first thing you look for is a common factor, and there's a common x, which would leave me with 25 minus x squared. And then hopefully everybody recognized that factors further. So that's x times 5 minus x, 5 plus x. 4x squared is pretty much prime. Second numerator, there's a common factor of 2, leaving me with x squared minus 1. And that x squared minus 1 factors further into x plus 1, x minus 1. That next denominator, let's see, I don't think that there's a lot of choices. X squared is x and x. 5 is only 5 times 1. My same signs are the same, both minus. And if I FOILed that out, it would give me the negative 6 in the middle. That next numerator only has a common factor of 7, leaving me with x plus 1. And then that next denominator has a common factor of x, leaving me with x plus 5. Looking at it in factored form, I find it easier to find the values to exclude. Here, we would have to exclude, to set that first denominator to 0, x would be 0. That second denominator, now that it's factored, hopefully everybody sees those factors would be 0 when x is positive 5 and positive 1. This next one would be when x is 0, which we have already, when x is negative 5. And then the one that we flipped, that would give me also when x plus 1 is 0 or negative 1. So we've got all those values to exclude. Now, multiplying, I cancel out what's common to the numerator and denominator, the x minus 1, the x plus 5, and the 5 plus x. Now, over here, does everybody remember x minus 5 and 5 minus x are opposites? And so those opposites, when I cancel, because they're opposites, remember we have to multiply by negative 1. And then I can also cancel out these factors of x. And I can put 2 into 4 twice. So what I have left in the numerator is 7 times x plus 1 times x plus 1. We'll usually write as x plus 1 squared. And in the denominator, I think all that's left is the 2x squared.
Didn't you multiply by -1?
Yes, thank you. Thank you, thank you, thank you. I need a minus sign out in front of the whole thing. Make it a negative fraction. It's probably the easiest way of showing that -1. Thank you. Don't be blind like me and miss it.
It's technically a Monday, don't worry.
Yeah, and actually, you know what? I could lie and say I did that on purpose to see if you'd notice. Right? Okay. So division's not a heck of a lot different than multiplication. We have to just change that division into a multiplication problem first. And please notice, it's almost counterintuitive. Before I multiply, I unmultiply, I factor. Because it's much easier to reduce factored as opposed to if I would have multiplied that all out, the factoring would have been a bin. All right? If multiplication and division are all right, then the next place we're going to do is we're going to look at addition and subtraction. Of these rational expressions. And let's look at an example like 3/16 plus 5/16. Does everybody remember, in order to add or subtract, they must have a common denominator? And so we keep that common denominator. Since these are both 16ths, my sum will be 16ths. And we add or subtract, if it's a subtraction problem, the numerators. Plus 5 is 8. And then we simplify. Remember, in order to simplify, we have to factor first, if possible. And so I look at 8 and 16, and I realize that they both have a common factor of 8. So this would reduce to a half. Numerically, does that process look vaguely familiar?
Sure.
So let's look at some algebraic fractions. Let's look at 3x plus 2 over 3x plus 4 plus 3x plus 6 over 3x plus 4. And to start with, we're going to do some of these simpler ones. We already have a common denominator. We're going to keep it. Sorry about that, folks. I'm going to add the numerators, combining like terms that would give me 6x plus 8. And then I think that factors. 6x plus 8, there's a common factor of 2, leaving me with 3x plus 4. And now that it's factored, I can divide those common factors out, and my final answer is 2. And if I'm adding, it's just combining like terms across. I'm going to add, watch your signs if it's subtraction. Let's say I have 2x plus 3 over 3x minus 6 minus 3 minus x over 3x minus 6. Got that common denominator, so I'm going to keep it. And to avoid sign errors, because this is subtraction, I'm going to write my subtraction in the numerator. And then does everybody remember, in order to do that subtraction, we want to think of distributing a -1. So that's going to be 2x plus 3 minus 3 plus x over 3x minus 6. And so now combining like terms, I get 3x over 3x minus 6. And that looks like it's full of multiples of 3. Let's see if we can factor and reduce. I'll leave that as 3x. In the denominator, I have a common factor of 3. Taking that out leaves me with x minus 2. I can divide out those 3's. And so my final answer is x over x minus 2. And is everybody all right? I have to stop there because now both numerator and denominator are prime. They can't factor any further, so they don't have any common factors. So far, if I'm adding and subtracting and I have a common denominator, is everybody all right? Just keep that common denominator. Where the problem arises is if you don't have a common denominator, you must first find, usually we look for the LCD, the least common denominator. To do that, we're going to factor each denominator. And so this time we only have to factor the denominators. And the least common denominator is the product. So we're going to multiply of all the factors. On any common factor, we'll use the highest exponent. Crap. What does all that mean? Let's look at an example. Let's look at 3 over 2x plus 4 plus 2 over 3x plus 6. It's obvious, I hope, that those denominators are different. So what I want to do is factor each just the denominator. So this first denominator factors into common factor of 2. I'm left with 2 times x plus 2. This second denominator has a common factor of 3. When I take that out, I'm left with x plus 2. So now my lowest common denominator, I have to multiply all the factors. I need a factor of 2. I need a factor of x plus 2. But they both have that x plus 2. Because neither of them have an exponent on it, I don't need an exponent there other than 1. And then I also need that factor of 3. So my common denominator is 6 times x plus 2. Now what we have to do is we need to express each fraction in terms of the least common denominator. To do that for each fraction, I'm going to multiply both the numerator and denominator by any factors of the least common denominator that are not already factors of the denominator. What's important is you must multiply the numerators. You want to keep the denominators in factored form. Do I need to wait a minute? Or is everybody ready to see what the hell that all means? You okay?
Yeah.
So the first fraction we have is 3 over 2 times x plus 2. And we wanted to get that common denominator of 6 times x plus 2. In order to turn the one into the other, does everybody see we have to multiply by 3? And if I multiply the denominator by 3, I have to multiply the numerator by 3. I always take the time to write this because if I'm making sure 3 over 3 is just 1. I want to make sure that I'm doing the same thing top and bottom, that I'm only multiplying by 1. So I don't change what my fraction is equal to, just what it looks like. And so I've got to multiply the numerators out. That'll leave me 9. That's one fraction. Now I've got to do the same type of work with the other fraction. This time, in order to get that denominator to be the same, I have to multiply both by 2, leaving me with 4. Now that we've got the common denominator, we're going to add or subtract, depending on what the problem is, the numerators. Keep the denominator. We've worked hard to get it. And then we're going to simplify if possible. Before we do that simplifying, remember, in order to simplify, you have to factor your numerator. Your denominator should already be factored. So what's that all about? I've changed my addition problem to 9 over 6 times x plus 2 plus 4 over 6 times x plus 2. I worked hard to get that denominator, so I'm going to keep it. And when I add the numerators, 9 plus 4 is 13. This would be my final answer. It doesn't reduce. Hopefully everybody recognizes that 13 is a prime number. And there's no common factor. Let's try a couple more. Is everybody done with this one?
No, can I have like 30 seconds?
Sure. Thank you for answering. I was getting scared when everybody was quiet that long yesterday. I realized that I missed the class. Got booted. I guess it's only fair if you guys get kicked out by Zoom every once in a while. I should too, huh? So let me know when you're ready.
It happens. Fun of the internet.
It's a love-hate relationship, right?
Yeah.
Yeah. Some things seem so much harder pre-internet days, and yet it seems like in pre-internet days, people did a lot more stuff and a lot less staring at stuff.
Mm.
Now, something got lost in making our lives easier. Is it okay if I turn the page? So let's look at 3x over x plus 4 plus 6 over x plus 5. First, I want to find my common denominator. Is it obvious to everybody that neither of those factor? So first one, I need a factor of x plus 4. Second one, I need a factor of x plus 5. And so my common denominator is that product. I like to say that when I look at my common denominator, I should be able to physically see all of the factors of each denominator in there. So this first fraction, 3x over x plus 4, if I want the denominator to be x plus 4 times x plus 5, is it obvious that I have to multiply the denominator by x plus 5? And again, if I do that denominator, I want to do the same thing to the numerator. I want to make sure I'm just multiplying by 1. Denominator, I can leave factor. Numerator, I want to multiply that out. 3x squared plus 15x. And that was so much fun. I want to do the same type of work with my second one. 6 over x plus 5. To make that denominator my common denominator, x plus 4 times x plus 5. Oh, it's missing that factor of x plus 4. So I'm going to multiply both numerator and denominator by that missing factor. Then I can leave the denominator factored, but I want to distribute the numerator, 6x plus 24. Now that I have a common denominator, I can add them. I worked hard for that denominator. I'm going to keep it. Because it's addition, I'm just going to combine like terms. So we've got the 3x squared, 15x plus 6x is 21x. And then I have the 24. To see if that's reducible, we might try to factor the numerator. Does everybody see there's a common factor of 3? And when I take out the 3, I'm left with x squared plus 7x plus 8. And I don't think that x squared plus 7x plus 8 is going to factor. I don't think we can come up with factors of 8 that add to 7. So this non-factored numerator will be my final answer. How's that one look? Let's try a subtraction that involves maybe a few more factors. Is everybody okay if I turn the page? Or do I need to wait? Not hearing anything, I'm going to turn the page. Let's look at 3x over x squared plus 3x minus 10. This time, let's make it a subtraction problem. Minus 2x over x squared plus x minus 6. Those denominators are different. I need to find a common denominator. In order to do that, I'm going to just factor my denominators. I think we've already factored x squared plus 3x minus 10, x plus 5, x minus 2. And let's see, x squared plus x minus 6, x multiplied to 6 with different signs, let's say 3 and 2, plus 3 minus 2 is going to give me that positive in the middle when I multiply it out. For my common denominator, from the first one, I need factors of x plus 5, x minus 2. From the second one, I need a factor of x plus 3. And I need a factor of x minus 2, but does everybody see it's in there already? Since neither of these have an exponent, or I guess technically, I shouldn't say they don't have an exponent. Since both of these only have an exponent of 1, I only need that one factor there. So now my 3x over x plus 5, x minus 2. What do I have to multiply that denominator by to get x plus 5, x minus 2 times x plus 3? Is it obvious what's missing is the x plus 3? And this is where I want to make sure I'm only multiplying by 1. I'm going to multiply the numerator and denominator by the same thing. Denominator is already factored. We'll leave it that way. Numerator, we have to multiply out so that we can add. So that's 3x squared plus 9x. With the other fraction, again, I guess it's a matter of personal preference. Because this is subtraction, I could go ahead and change that into adding a negative, but let's keep this as subtraction. I've got 2x, x plus 3, x minus 2. I'm missing that x plus 5. Got to do the same thing, numerator and denominator. The denominator, I'll leave it factored. The numerator, when I distribute, gives me 2x squared plus 10x. So now, when I go and do my subtraction, I've got that common denominator, so I'll keep it. And I'll just subtract those numerators. In order to do that subtraction, I want to think of distributing a -1. Be careful with your signs. So that numerator is 3x squared plus 9x minus 2x squared minus 10x over that common denominator. And combining, that's going to give me x squared minus x over that common denominator. And then again, to see if it would be reducible, I'm going to try to factor that numerator. That numerator factors into x times x minus 1. There's no common factors, so that will be my final answer. It does not simplify. Let's try one more of these before we start looking at complex fractions. Can I turn the page? This next one, did you folks want to also do together, or did you want to try it on your own first? Together or alone, folks, what's your preference? Can you guys hear me?
Yeah.
Yeah, together or alone?
I think it's better. I think it's better usually together.
So doing this together, their first denominator, let's see, x squared will be x times x. 25, if I use 5 times 5, the signs are the same, both minus. So that one's actually x minus 5 squared. Hopefully everybody's comfortable with the difference of two squares. That'll be x plus 5 times x minus 5. Factors that I see, I've got x minus 5, and I have x plus 5. But over here, because I've got an exponent on the x minus 5, I have to keep it. So my common denominator is going to be x minus 5 squared times x plus 5. First fraction is x over x minus 5 squared. To get that denominator, I think we need to multiply by x plus 5. Again, we want to make sure we're multiplying the fraction by 1, not changing what it equals, but what it looks like. And in distributing the numerators, I get x squared plus 5x. Next one, in order to get that x minus 5 squared times x plus 5. Let's see, we had a denominator x minus 5 times x plus 5. Our numerator was 5. We need that second x minus 5. So we're multiplying numerator and denominator by that. So that's going to give me 5x minus 25 over my common denominator. Now that I've got that common denominator, I'm going to keep it. And I'm going to add my numerators. Combining like terms, that'll give me x squared plus 10x minus 25 over x minus 5 squared times x plus 5. And because this is a minus 25 and this is a plus 10, This numerator is prime. It can't factor. So that'll be my final answer. Okie dokie. Any questions? Not hearing anything, then the last thing that we want to look at in section P are complex fractions. And complex fractions contain a fraction within the numerator or the denominator, or both, of the fraction. They're called complex because they look pretty complicated. So let's start with a pretty simple example. I have x over 3 minus 1 over x minus 3. And we want to simplify it. There's a couple of different approaches. I think the one that is least work is to first find the least common denominator of the fractions within the fraction. And so here, when I look at this fraction, I see it containing 4 terms. Between those 4 terms, the ones that aren't fractions have a denominator of 1. So between those 4 terms, does everybody see there's only one denominator? So the least common denominator would be that 3. Then what I'm going to do is I'm going to multiply both the numerator and denominator of the complex fraction by that least common denominator. Sometimes I think of it as the least common denominator over 1, and I have to distribute if necessary. So again, my original complex fraction was x over 3 minus 1 over x minus 3. The common denominator is 3, so I'm going to multiply both numerator and denominator by 3. I have to distribute both in the numerator and the denominator. So distributing is going to give me 3 times x over 3 minus 3 times 1 over 3 times x minus 3 times 3. Over here to multiply that fraction by 3. This is where I'm going to think of that as being 3 over 1. When I do that multiplication, I'm left with just x. 3 times 1 is 3. And then in the denominator, when I distribute, I'd get 3x minus 9. After you do that step, there should be no fractions left within the complex fraction. And so now I'm going to simplify if possible. And remember, in order to simplify, we have to factor first. And so as I look at that numerator, x minus 3 is prime. It does not factor. In the denominator, does everybody see I have a common factor of 3? And when I divide that out, I'm left with x minus 3. Now I do have this common factor of x minus 3. So my final answer is 1/3. What do you think? Shall we try another? Does anybody need a minute with it, or are we okay? Next one, let's simplify. And let's look at 1 over x squared plus 2 over x minus 3 over 1 over x squared plus 1. Now, to find the least common denominator, I want to find the least common denominator between the 5 terms that I have in this complex fraction. Well, the only factor I see in those denominators is x. The highest exponent is 2. So my common denominator is going to be x squared. Is everybody comfortable with that decision?
Yeah.
So then I'm going to take my 1 over x squared plus 2 over x minus 3 over 1 over x squared plus 1. And I'm going to take both the numerator and denominator and multiply them by x squared. I have to distribute in the numerator. So that'll give me x squared times 1 over x squared. So I think I'll put that 1 over 1. Plus x squared times 2 over x minus 3 times x squared. In the denominator, that'll give me x squared times 1 over x squared. And I think that's easier to see if we put it over 1. Plus 1 times x squared. My God, that looks worse, not better, doesn't it? But in taking each of these products, here the x squareds cancel, and I'm left with 1. Here, x is a factor of x squared. I'm left with a single x times 2. And then the 3x squared does not need to do anything else. Here, the x squareds cancel, so I'm left with 1 plus x squared. 1 plus x squared does not factor. So I don't think it'll have any common factors with the numerator. And so this would be my final answer. Does that look less complicated than my original problem? You don't want to leave complex fractions. You don't want to leave fractions within a fraction. I'm looking, there's one more that I wanted to do, but I don't think there's enough time. So I'm going to make note of the fact that we've done three of the examples, and there's one more that I want to do, but we have finished these complex fractions. So if I go back to the first page, this homework that's due by the 19th, try to get it done by the 19th. Depending on how it goes, we'll see, whether we need to push that back a day. But what I'd like to do next class is do just one more example of the complex fractions, answer any questions that you folks have, and then work through one iteration of the problem set so that you have an idea of what's going to be on that test. Then the test will be open over the weekend. Any questions?
When will the test be open?